Hi friends, today let's look at the problem of finding maximum number of flights which can be on the air. The problem states that we are given a list of flights describing their start time and end time, that is start from a particular airport and end or departure at a particular airport and land at a different airport. Our objective is to find at a given point of time how many number of flights are on the air. To solve this problem, if you look at, I'll take you to a simple example. Let's say we are given with 3 flights describing 1-2 as its start time, 3-5 as its start and end time at a different flight, and 4-10. If we observe that the number of flights, the maximum number of flights that can be on the air is 2 in this particular case, because 3-5 and 4-10 are overlapping. So that means the flight which has started at 3 and it lands at 5, the flight which starts at 4 and lands at 10 are both are on the air at a given point of time, that is at a 4 o'clock. See, and 4 to 5 they both are on the in the air. So we consider that at this point the maximum number of flights are on air. 1 and 2 has been started earlier. Here the maximum number of flights on air is only 1. By looking at this problem, now however the order of the flights are given to you, we're going to have a sorting. We're going to sort their start times such that we know that when do all the flights start. So that's our first step. So we're going to sort the input array of flights, and secondly we are going to identify the overlapping flights. What are we doing here? So we'll try, let's say this is a sorted order of list. Now we take the first flight, so it starts at 1 and ends at 2. When we look at the second flight, they are not overlapping. That means they both are not on air at a given point of, at any given point of time. So we know that there is only one flight that can be on air up to 3 o'clock. Now after this we take this flight and look at it and its subsequent flight. So in this case 3 and 5 and 4 and 10. But we identify that 3, 5 and 4, 10 are overlapping. That means there is a time window at which 3, 5 and 4, 10 overlap. So that means these are the flights which are on air at the same point of time. Let's say there is another flight which is starting at 6 o'clock and ending at 10 o'clock or 10 o'clock, 12 o'clock I would say. So that means now the flight which is 3, 5 and 4, 10 and 6, 12 are all overlapping, or they can they be all in the same time? No. In this case the maximum flights on this still is 2, because 3, 5 and 4, 10 are overlapping at a certain point of time, but after 5 o'clock till 6 o'clock only this flight and this flight is overlapping. So that means this is only 2 flights are still overlapping. But what if this third flight is going to start at somewhere at a 4 o'clock? Then there are 3 flights which are on air at a given point of time. So now let's look at the solution. We'll start it from, so first let's define the flight. The flight is a data type. So in Golang we define flight with start and end points, and I also defined another type called flights, which is a list of flights. So that's the input for us. And let's look at the functionality, max flight on air, which gives you a list of flights input defining their start time and end time. We see if there is a no flight is given to us as a valid input, we'll return simply the number of flights that can be on air is 0. Else we're going to populate your data structure, prepare the flights, and call get max flights on air. The get max flights on air API as our function is going to do, the first step is sorting. I'll just write it here. The first step is sorting. Second step is at any given point of time there will be at minimum of one flight in air. So that's this initialized to 1, and the current flight that it is going to run is the current number of flights on air is 1. That's what we start with. Then the first flight that could be on air is the F1, the first flight in the list of flights, because we have sorted them. Now once you have this, and we will iterate over the other flights, and we'll take the first flight. So in this example we are taking 1, 2 and 3, 5 and start comparing them. Are they overlapping? If they are overlapping, that means those both flights are going to be on air for a certain point of time. So we need to increment the number of flights on air by 1. That is the statement. And we will see if the current number of flights are more than the result where maximum number of flights, then we're going to set it. If they are not overlapping, which is the case here, 1 2 and 3 4, what I'm going to do is this, the maximum number of, I will not update the maximum number of flights. All I look at is 3 5. I will reset my current number of flights on air is going to be 1, and I will make this next flight as my starting flight and then move. So basically I'm basically sliding through each flight and see whether they overlap with the previous flight. If they are not overlapping, we reset the count, we reset the window, we reset the window, and then we will start afresh. That's the idea. And then we return the maximum flights. Here to call out, I have implemented something called sorting functionality. Golang doesn't have generics. So you will see we have to implement the sorting functionality on the flights data type, which implementing these 3 methods. That's what these are. And on flight we will check whether it's overlapping with a different flight. That's the method on the implemented on the flight. That's all. Let's run this. Some of the examples that I have made taken is 2 examples. One is 4 8 2 5 17 20 10 21 and 9 18. If you see this example, the maximum flights that can be on the air are around 3. So we see 10 21 overlapping with 9 18 and 17 20. So these 3 are the flights which are overlapping. So we'll see an answer of 3. And the test 2 ke liye, if you see, they both are non-overlapping. So at any point of time, we will have only 1. So I'll call for test 1 and test 2 in main function for testing. The output is expected to be 3 1. That's all I have. Now let's look at a time complexity and space complexity of this problem. The time complexities we are using sorting, which is going to be n log n. So this is the time complexity, that's n log n. And the space this is going to take an order of log n because we are iterating through the list of sorted flights, order of n. Thus the total time complexity will be n log n plus n. So asymptotically it is n log n. Can we do better? Even if we use heap, we have to look for every flight, so it's still going to be n log n. So we are okay to do sorting. So n log n is the best we can do. And let's look at the space complexity. The space complexity is going to be, I'm just taking a flights input array which is order of n to map it. So the space complexity is order of n. That's all I have. If you like this video, please subscribe, please like this, and reach out and forward this to share with your friends so we can all learn together. Thank you.